Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alright, for now, we from Group C want to present about our group assignment. The article that we take, the case is transmission system frequency incident. My name is Muhammad Zahir bin ABIDIN. My friend, Muhammad Amir Syahir bin JAMAL ABANA, NASRULLAH ZIKRI bin ZULKIFLEE, and HUAN. Okay, for the detail of this incident is happened at Great Britain. The transmission system was the side effect of a lightning strike, suddenly lightning strike at 4:52 p.m. on Friday, August 9, 2019. Okay, this led to the loss of two large generation sources as well as a significant quantity of distributed generation. System frequency eventually dropped from 50 Hz to 48.1 Hz, triggering. For the first time in 11 years, the system operators under frequency load shedding mechanism known as low frequency demand disconnection, which disrupt energy supplies to around 1.1 million clients. During rush hour period, the event also triggered disruption to rail, which is train, impacted critical facility including airport and hospital. Okay, this is the graph of the frequency happen at the incident. From 50 Hz, it fall to 48.8 Hz. Okay. All timeline of all event and response is necessary in order to fully model the incidents totally. Because of the seriousness of the incident and the thoroughness of the subsequent investigation, a comprehensive account of the occurrence is now available to the public. So, the August incident was multifaceted. There is a degree of uncertainty regarding the actual magnitude or timing of a number of event part, as we can see at the table 1 in the left. This table details timeline of loss of in-phase events and system responses modeled during the first 100 of the August 9th frequency incident. We can see this graph 2 had final outcome of the event replication procedure in view of the fact this is still below the total expected event, the magnitude of 1,561 megawatt. The system frequency is continuing to decrease as shown in the graph below. Okay. As why the protection system is involved in this accident? The protection system that involved in this accident because it happened the breakdown and system frequency responses, as displayed in figure 1 below. Figure 1 at the left.
And this is the main cause of the incident Great Britain power system disruption on 9 August 2019. So the main cause of initially found by ESO's technical reports for 5 or 6 of September shows that the incident is thought to have been caused by a lightning strike to an overhead transmission line and the near simultaneous loss of number of generators at approximately the same time. The system response backup generator held by ESO at the same time of the incident was just over 1,000 megawatt. However, the total generation loss from the affected power station and a number of smaller generators as a part of an initial event was at least 2,000 megawatt, greater than the response held. This loss caused the system frequency to drop below the statutory limit of 49.5 Hz to 48.8 Hz. Once the frequency of the system dropped to 48.8 Hz, the stage 1 of 9 of the automatic protection system known as low frequency demand disconnected LFDD was triggered. And this is the impact consequence of the incident. So for the first is the safety. while around half the affected train was restarted by their driver. The rest require engineers to be dispatched blocking track and causing huge disruption on line onto St. Pancras International and King's Cross. 371 services were cancelled and 873 delayed, despite this train being unaffected by the power issues and disrupting thousands of customer journeys. This led to St. Pancras International and King's Cross and Euston Station have to limit the passengers' number while entering the station at various times. But the second is the health. 2 hospitals was affected by LFDD with their backup generation work as designed. This was due to incorrect protection setting on the hospital's on network, which result in the site switching over to the back generation and one of its 11 generators failing to operate. So the third is the cost. The coincident losses of generation causing the level of distribution are rare with only one previous event on 27 May 2008 over past 25 years. The frequency response and reserve service cost the ESO more than 270 million in 2018 and 19. For the fourth is the damage of the incidents. So the lightning strikes are the frequent occurrence on the electricity network and rarely cause significant disruption. On 9 August, a lightning strike on 4:52 p.m. on a 400 kV overhead transmission line in Cambridgeshire was followed by generation losses at least.
From the technical report, it is important. What can we learn is it is important to review the processes and protocol of communication, particularly during the first hour, in order to facilitate timely and efficient communication in the event of any future incident. Besides that, the list of facilities that are connected to the LFDD scheme needs to be reviewed to ensure that no essential service or infrastructure are unnecessarily put a risk of being disconnected as a result of an oversight. Okay, LFDD is triggered if frequency on the transmission system drop below 48.8 Hz. It aims to preserve the integrity of the system by holding the frequency above 47.5 Hz. That is the function of LFDD. The following step is to conduct an audit of the configurations of the internal protection system installed on electric trains. This will ensure that the trains can continue to function normally even when confronted with normal disruptions to the power grid. Next. Well, for the health, radiation from high voltage power lines can cause a variety of health problems, including insomnia, anxiety, headache, skin burns, fatigue, and muscle pain, according to the finding of research conducted by the World Health Organization (WHO). In order to avoid electrical risks and hazards, certain precautions must be taken. Some of that is climbing a tower with a live conductor is dangerous because it can result in electric shock. Tying animals to transmission power or poles is dangerous and should be avoided at all costs. A metal or conducting object should be not thrown on overhead power lines. Towers or poles should not be touched during rainy weather because the conductivity of water energizes the tower body. Okay.
Okay, next is what has been done to prevent this event from happening in the future. So to prevent this happen is increasing number of generators or interconnectors that make use of power electronic converters. This allows much greater control flexibility relative to traditional directly connected electrical machine. So number 2 is swift completion of the accelerate loss of main chain program would provide immediate benefit to system operation while any inability to achieve full coverage. Number 3 is improved monitoring of the delivery of response service should provide a greater incentive for providers to meet contract obligation and improve overall delivery rates. So net to prevent this happen is engineer standard clearly define roles for the sector, various license holder and codes for governing the relationship between them are critical to getting both the engineering and the commercial relationship right among so many different actors. So number 5 is review the security standard, that is SQS, to determine whether it would be appropriate to provide for higher levels of resilience in the electricity system. This should be done in a structured way to ensure a proper balancing risk and costs. So last is review the timescale for delivery of the accelerate loss of main chain program to reduce the risk of inadvertent tripping and disconnection of embedded generation. SGB move to ever increasing level of embedded generation. So that's all from us. Thank you. Stop.